In this video, we're going to talk about vectors. Here's a list of items I intend to cover. We'll talk about vector types, creating vectors, vector indexing, manipulating vectors, vector operations, vector functions, and naming vector elements. R has two types of vectors, atomic and recursive. An atomic vector is a data structure in R that contains elements of the same type. For example, you might have a vector that contains only integer values. A recursive vector, which is also known as a list, allows elements to be of different types and is much more flexible. Just as a side comment, I rarely hear people refer to this data structure as a recursive vector. The name list is much more common. Let's talk about the different kinds of atomic vectors. There's logical, integer, double, character, complex, which refers to complex numbers, and raw. Let's talk about each of these different types, starting with logical vectors. The elements of a logical vector can only be one of three possible values: false, true, and NA. Let's look at an example. So how do we even create a vector? Well, we use the C function. C stands for combine because it combines elements into a vector. C can actually be used to combine elements into a list, but the default behavior is a vector. Okay, so I created a vector using the C function containing the elements true, true, NA, and false, and I assigned it to the name logical_vector. And then I type the name, press the return key in the R console, it outputs the elements of the vector. Okay, let's talk about integer vectors now. In R, integer numbers are doubles by default, but we can change this behavior by using the L character. In this example, I created a vector using the C function containing elements 1, 2, 5, and 6. Since I attached the L character to each of the numbers, it tells R to treat them as integers. Integers have one special value, and that value is NA. This means when I create an integer atomic vector, I can use an integer or an NA, but no other element. Since integer numbers are doubles by default, dropping the L character creates doubles and not integers. Doubles have their own special values as well, except that they have 4. There's not available, not a number, negative infinity, and positive infinity. So that means when you create a double atomic vector, you can put in a double or one of these 4 special values and no other elements. So here I show an example of this. On the first line, I create a vector using the C function, and I put in the elements 10, -1, not available, infinity 5, not a number, and minus infinity. The output of the integer vector 1, 2, 5, 6 and the double vector 1, 2, 5, 6 looks the same in R, but you can confirm the different vector types by using the type of function. Let's look at some examples. First, I create an integer vector 1, 2, 5, 6, then I create a double vector 1, 2, 5, 6, and you can see the R output looks identical. However, confirming with the type of function, the first vector has type integer and the second vector has type double. Let's talk about type mismatches. When element types mismatch, the C function automatically tries to coerce the elements to a common type. So if you look at the example on the screen, I first create a vector x with elements 1, 2, 3, and 5L. So the first 3 elements will be interpreted to have type double, and the last element 5L will have integer type. However, when creating an atomic vector, all the types must match. So R is going to take the 5L and coerce it to a double. We can confirm this by using the type of function. So when I type of parentheses x, the output is in fact double. Let's talk about character vectors. Each element in a character vector is either NA or a string defined by wrapping characters with single or double quotes. I put a simple example on the screen where I use the C function to create a character vector. The first element is the empty string, and the last element is not available. In terms of complex vectors, a complex vector is a vector where each element is either a special value or a complex number. I'll also note that if you want R to recognize I as a complex number, this can be accomplished by writing one I instead. I hardly use these in practice, so I probably won't cover them much further, but I just want you to be aware that they exist. Another uncommon vector type is the raw vector type. The elements of raw vectors are raw bytes of data and can be created using the raw function. I probably won't cover these further, but I just want you to be aware they exist. In my videos, I'm probably going to just concentrate on logical, integer, double, and character vectors. Let's talk about vector indexing. The elements of a vector are accessible via square brackets. For example, you can use x square bracket 1 to access the first element of a vector x, and x square bracket 3 to access the third element of a vector x. You need to be careful because, unfortunately, if you use an index beyond the length of a vector, R will not complain or notify you. Let's look at an example. Here I created a vector containing elements 2, 5, 7, 9, and minus 1. So recall the vector type here is double. To access the first element, I typed x square bracket 1, and R outputted 2 as expected. X square bracket 2, R outputted 5 as expected. However, there's only 5 elements in the vector, yet R still outputted a value when I typed x square bracket 10. If you're familiar with other programming languages, using a negative index may not behave as you expect. For example, suppose x is a vector, then x square bracket minus 1 will return the vector x with the first element removed. Similarly, x square bracket minus 2 will return the vector x with the second element removed. A more general notation is to actually pass a vector as the index. So here I'm just noting that x square bracket and then vector containing minus 2 has the same behavior as x square bracket minus 2. In fact, the vector can have more than one element. So x square bracket and then inside is a vector with both minus 1 and minus 2 will actually return the vector x with the first 2 elements removed. Let's look at an example. In the first line, I create a vector x with element 0, 2, 4, 6, 8, 10. Then I type x square bracket minus 1, and R returns the vector x with the first element removed. Then I type x square bracket minus 2, and R returns the vector x with the second element removed. In the next line, inside the square brackets, I pass a vector containing the element minus 2, and as you can see, the output is the same as the previous output. In the last example, I pass inside the square brackets a vector containing minus 1 and minus 2, and R returns the vector x with the first 2 elements removed. This also works for positive indices as well. So here's an example displaying that. I create the vector containing 0, 2, 4, 6, 8, 10. I pass the vector containing elements 1, 3, 5 inside the square brackets, and I get back only the first, the third, and the fifth elements of the vector x. Now I want to talk about logical indexing, which is an extremely important concept because it can make your code much faster and more scalable in various situations. But the idea is that you pass a logical vector as an index to subset another vector. Let's look at an example. So first I create a vector x containing the elements 2, 5, 7, 9, and minus 1. So the length of the vector x is 5. I'll create another vector y having the same length as x, except that the only elements of y are true or false. Now imagine we put the vectors x and y side by side, and then we paired each corresponding element. So 2 gets paired with true, 5 gets paired with true, 7 gets paired with false, 9 gets paired with false, minus 1 gets paired with true. When you pass y in as an index to the vector x, it's only going to return the vector x where the corresponding elements are true. So since 2 was paired with true, 5 was paired with true, and minus 1 was paired with true, when we imagined x and y side by side, then x square bracket y will only return 2, 5, and minus 1. Now, I'll just note a very important caveat. If the logical index is not the same length as x, vector recycling will silently occur. So this is very important because this could lead to mistakes or errors in your code. So say y was one element short. Then what's going to happen is vector recycling will occur until the length of y matches the length of x. So for example, if y had length 4, so it was only like the first 4 elements, true, true, false, false, then what's going to happen is y will repeat starting at the first element. So it will place another true at the end, and then it will stop because the length of y now matches the length of x. Suppose instead we defined y to be the first three elements, true, true, false. Then what's going to happen is the first two elements of y will be copied and placed at the end of y to stretch it to length 5, so that the operation x square bracket y makes sense. So this is an example of vector recycling. Sometimes we want to create vectors of numbers where the elements follow some pattern. This is where sequences may be helpful. Suppose a and b are numbers. The notation a:b may be used to generate a vector of numbers with first element starting at a and the next element equal to the previous element plus 1, but stopping before b is exceeded. Let's look at some examples. In the first example, I typed 1:10. So this is going to create a vector of numbers where the first element starts at 1, and then we'll keep adding 1 and stopping before 10 is exceeded. So we just get back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the next example, I typed -4:3. So here we get back a vector of numbers where the first element starts at -4, and then it will keep adding 1, but stopping before 3 is exceeded. In the next example, I type 1.2:7.6. So we get back a vector of numbers where the first element starts at 1.2, and we keep adding 1, but we stop before 7.6 is exceeded. The seq function in R can be used to generate sequences with more flexibility. If you open the R console and type help (seq), documentation for the function should pop up, and I just put it on the screen now. I ask that you bring your attention to the bottom of the screen under the section titled Usage. In that section, I see a comment that says default S3 method, and just below that, I see seq parentheses and then a bunch of parameter names. So the first parameter name is from, and its default value is 1. We know that because they typed from equals 1. The second parameter name is to, and its default value is also 1. I also see parameter names by, link.out, along.width, and ... So ... is notation that allows the function to accept an arbitrary number of arguments. Okay, let's look at some examples. In the first example, I typed seq parentheses 1,10,2. I didn't specify any parameter names, so R is going to assume that each correspond to the parameter name in the same order listed in the documentation. So 1 is going to be from, 10 is going to be to, and 2 is going to be by. So that means start at the number 1 and keep adding 2, but stop before you exceed 10. So we get back 1, 3, 5, 7, 9. The next example, I just specified the parameter names to show that we get the same output. In the next example, I specified from equals 1, 2 equals 10, but instead of specifying the parameter name by, I specified length.out equals 2. So that's going to just return 1 and 10 because I get back two numbers starting at 1 and ending at 10. In the next example, I just changed the length.out parameter from 2 to 4. In this case, the output is a vector of length 4 with first element 1 and last element 10, and each of the elements are equally spaced. In the last example, I just didn't specify the from equals or the to equals, but as you can see, we get the same output as the previous example. Okay, let's talk about repetition. There's an REP function in R, so REP stands for repetition, and the first parameter is x and the second parameter is times. And this function is used to repeat the elements of x according to the elements of times. So let's look at a couple cases. If times is a single integer, the result is simply x repeated the value of times. If times is a vector having the same length as x, then the result is the first element of x repeated the first element of times. The second element of x will then be repeated the second element of times, and so on. Let's look at some examples. In the first example, I typed rep parentheses 1 comma 6. So 1 is going to be repeated 6 times. In the next example, the vector 1, 2, 3 is going to be repeated 3 times. That's why you see 1, 2, 3, 1, 2, 3, 1, 2, 3. The next one's a little bit trickier. So the vector 1, 2, 3 is going to be repeated in a special way. The first element 1 will be repeated 1 time. The second element 2 will be repeated 2 times. And the third element 3 will be repeated 3 times. That's why you see 1, 2, 2, 3, 3, 3. Okay, let's talk about vector addition. To add a constant c to each element of a vector x, you can use c plus x, or you can use x plus c because addition is commutative. Let's look at an example. First, I assigned -1 to c, then created the vector x containing element 0, 1, 1, 0, and then I typed c plus x, and as you can see, it just took each element of x and added -1. To multiply each element of a vector x by a constant c, you can use c times x or x times c. In the example on the screen, I assign 2 to c and then create the vector x 1, 2, 3, 4, 5. Then I type c times x and then type x times c. You can see the outputs are identical and each element of x was just multiplied by 2. Suppose x and y are two vectors of the same length. The two vectors can be added element-wise by typing x plus y in the R console. Let's look at an example. So first I create a vector x containing elements 1, 2, 3, 4, 5. Then I create a vector y containing elements 6, 7, 8, 9, 10. Then I type x plus y. So what this is going to do is perform element-wise addition. So 1 will be added to 6, 2 will be added to 7, 3 will be added to 8, 4 will be added to 9, 5 will be added to 10. So that's how we get 7, 9, 11, 13, and 15. Let's look at other examples of element-wise operations. So first I'll create a vector x containing elements 1, 2, 3, 4, 5. Then I type x to the second power. What that's going to do is take each element of x and square it. In the next example, I type x times x. So that's going to take each element of x and multiply it by itself. So that's the same thing as x squared. I can also type x divided by x, and that will take each element of x and divide it by itself, which is why you see a vector of 1s. And then finally, I can take a vector 1, 2, 3 and raise it to the power of a vector 1, 2, 3, and that's going to take 1 to the first power, 2 to the second power, 3 to the third power. So these are examples of element-wise operations. We talked a little bit about vector recycling previously in this video, but I just want to explicitly write out an example so that the concept might be a little bit clearer. So recall that if you try to add two vectors and one is shorter than the other, then R will recycle the shorter vector until it matches the length of the longer vector. So here, the vector containing elements 1, 2 is 3 elements shy of the vector I'm trying to add it to. So R is going to silently change the vector 1, 2 to 1, 2, 1, 2, 1. And now it has length 5 matching the length of the vector I'm trying to add it to. And so now we can perform element-wise addition. Okay, so hopefully this example made it a little bit clearer. Let's talk about naming vector elements. Vector elements can be named during creation with the C function and referenced using the names. So normally when I create a vector x, I would just write C parentheses 1, 2, 3. Here, I'm writing A equals 1, comma, B equals 2, comma, C equals 3. So this is going to say the first element has name A, the second element has name B, and the third element has name C. And then when I type X and press the return key in the R console, it outputs the vector, but it also includes their names above the element values. And then when I type x square bracket 1, it returns the first element 1, and then it also puts its name a on top. I could also reference the elements of x using their names as well. So I could type x square bracket quote a, so basically give me the element in x that has the name a, and as you can see it outputted 1. And then it also shows its name above it. I could also pass a vector in as an index, where the vector is a vector of names. So here I type x square bracket, and then I create a vector containing the names a and b, and then of course it returns the elements with names a and b. Vector elements can also be named after creation. For example, suppose I create a vector x containing elements 1, 2, 3. If I type names parentheses x, the output will be null because names don't exist. But I can assign x names by typing names parentheses x and assign it a character vector, and I'll just choose names a, b, and c. And if I type x and press the return key, you can see the elements 1, 2, 3 and their names a, b, c written above. And then if I type names parentheses x, it outputs the character vector a, b, c. Okay, the last thing I want to talk about in this video are attributes. Object attributes may be accessed via the attributes function. Calling this function will either return null or useful information about the object. So let's look at an example. Suppose I create a vector x with elements 1, 2, 3. If I type attributes parentheses x, the output is null, which basically means x doesn't have any attributes. Notice that if I type names parentheses x and assign it the character vector a, b, and c, I've given x names. That creates an attribute. So if I were to type attributes parentheses x, you'll see that there's a name attribute, and it shows that it's the character vector a, b, and c. Okay, I hope you've learned a lot about vectors in this video, and if you like my videos, please subscribe to my channel. Hopefully I'll see you in the next video.